Okay. Thank you very much, Mauro. So the agenda for this afternoon, I'm going to give a very brief introduction, about 5 minutes. My role here is really only to warm up the audience for the two examples that we're going to show. The first example is essentially a pedagogical example, and I'll explain it quickly in a second, which will last around 45 minutes, and it'll be given by Jaime. You'll see all of the names in a second. The second example is a full 5G use case, which will also last around 45 minutes, and given by Pablo, Manuel, Diego, and Isaac. Okay, so the speakers. So I'm Raymond Knott from Eurocom, and as I said, I'm only going to talk for a couple of minutes. Then there is Jaime Garcia Reynoso and Pablo Serrano from Universidad Carlos III in Madrid. And then the Ericsson team, Manuel Lorenzo, Diego San Cristobal de Pasa, Isaac Quintana Fernandez from Ericsson in Spain. So Mauro already said this. If I could ask everybody to turn off their microphone, please. Somebody's keyboard is making a lot of noise in the background. Thank you. Mauro already mentioned this. If you want to ask questions, we will reserve the end of each presentation for questions. Please send us the chat indications, and if you can, with your name, institution, and your question. Then the organizer will either moderate or hand it over to you with the speakers. And again, we'll address the questions after each of the two presentations. Okay, so very brief introduction. This is part of the GE project, and today's training demonstrations are really highlighting the site in Madrid, in Spain. So the groups from primarily from Ericsson and Photonic, from IMDEA and Photonic, and also from University Carlos III are running the show today. So as Mauro said, this is really the first live hands-on tutorial where we'll see how to create an experiment, deploy and run an experiment, and how to collect measurements from an experiment. Before we talk about the two examples and from very high level, I just want to highlight a few things and also thank the people that were involved putting this together. Firstly, the content that we're presenting today, it does rely quite a bit on the previous training session, which was given a little over a month ago. For those that did not attend it, you can get in touch with us, and we will provide you all the necessary information afterwards. Please, we'd be happy to share that information with you to make you understand a little bit better what 5G is all about. Now, the initial target here was to do this with a real experimenter. So basically, the training team, which I'm part of, and a few other colleagues in the project, we were planning to play the role of an external experimenter. But it was deemed a little bit too risky at this point in our project to do this live with a real experimenter. Rest assured, the 5G infrastructure is now ready. You will see this today. But it's very fresh due to very understandable delays that came from the COVID-19 epidemic, as Mauro said. So what you should understand from today's demonstrations is this is something that an external experimenter is able to do, or at least will be able to do in the next couple of weeks. We're very, very close to opening this up to the outside world. What we've decided to do today, so that this would be as fluid a session as possible, is to allow the site maintainers themselves to operate the tutorial. And this is something that will be reproducible by the outside world. So in fact, even the first example that you will see, this is something that initial experimenters should try on their own afterwards. Before we get started, I think we owe a lot of thanks to the technical teams at the Spanish site and also some of the other 5G partners that were involved in this for putting this setup together. While they were still integrating the full system, and this is still, under very, very difficult working conditions. They've had remote access over the last 4 months exclusively, aside from a few people that could go in and perform some sort of maintenance. And I can say that there were very, very many hours spent by these people in the last 2 months. And to complicate matters, all of the information systems at Fivetonic had to be brought up yesterday due to a power outage over the weekend. So there was also lots of last-minute concentration needed to make this possible. So the people involved here really require a lot of thanks. And I'd also like to say there was very excellent coordination from the 5G EVES project and technical coordinators, Maro and Manel, who are online. It's not always like that in the EU projects, and especially in the last few months. To be able to put this together, they also require very special things. So just a couple of words on the two scenarios that you're going to see. The first one is a so-called pedagogical scenario. It's a simple web server deployment, but this is a deployment from A to Z, including running and collecting the measurements. You will see some of the under the hood visualization of the elements of the network, how the different elements like the portal, the interwork layer, the site orchestrator, and the cluster resources interoperate. And this really serves as a reference for any new experimenter to try out before deploying a more complex scenario on the 5G EVE network. So I think this is actually a very important example. Strictly speaking, it's not a 5G example, but it uses the machinery that 5G EVE has been putting in place. The second example is a real smart tourism use case from Segetur. This involves 5G non-standalone infrastructure, so a core network, an EPC with 5G control plane, and the radio access network. It includes a 5G end-user device and a sophisticated 360-degree video sensor. So basically what this example shows is the configuration of a real service and how to collect measurements on a deployed service and network. For the moment, what you will see, the measurements are local, but the whole system is being put in place so that these are also afterwards viewable in a remote location. Now, this example, different than the first one, should be seen as a fixed setup of vertical use case, which can be used by an experimenter to collect 5G KPI measurements that are pertinent to this particular use case. So this is an example where a vertical partner, in this case, the Segetur tourism operator, has deployed equipment on top of a 5G network, and an experimenter will be able to measure the performance of that combination, application and network. So the network configuration is fixed. Radio topology in this case is also fixed, but the measurements are real, and it's using a commercial 5G solution. So it's actually a very valuable setup for people that would like to do measurements. Now, for what you will also see is that for now, the network setup is not actually run via the portal as in the first case. But this will come soon. So I think it's time to start. So I'll pass it off now to Jaime, who will do the first example.
Okay, thank you, Raymond. Let me share my screen. Okay. Okay, I think that you are seeing my screen is not well. Let me swap this plate. Hopefully you can see only my main screen. Can you confirm, Raymond, please?
I can see your screen, yes.
Okay, thank you. Thank you. Well, yes, as Raymond said, my name is Jaime Garcia Reynoso. I'm from University Carlos III of Madrid. My name is only my name here, but there is a lot of people that has contributed a lot to make this simple use case possible. So thank you to all the 5G team. As Raymond has commented, this is a very naive use case. We call it the simple use case, and also known as the hello world that we can use in the, let's say, for these training purposes, let's say. Okay. So this is the agenda for this first presentation, for this first part of the training. Very simple presentation. First of all, I will try to give you a very detailed, well, not very detailed, but an overview of the 5G platform. And after that, I will go in deeper on presenting the simple use case. So let's start with the 5G platform. As you know, this 5G platform is let's say a project where we plan to offer this to the 5G experimenters, this 5G end-to-end facility, which will enable all these users to validate their network APIs, sorry, and services. Some very important concepts that we have to present before the training session is the following. We have to explain the actors and their tasks, the blueprints and descriptors, and experiment workflow. Okay, I will, as I said before, present a very high overview of all these points. And after that, I will redirect you to the 5G portal user manual that we plan to release in the next days. Okay, let's move to the next slide. Okay, so this is the first part of the presentation of this 5G platform, the actors. You can find more information about this in the deliverable 4.1 that you can find in our webpage in 5G. Remember that one of the main goals of this platform is to make as easy as possible for all our users to design, define, and also run their experiments. So the idea here is to make different roles available to the different users. Okay, so we have divided these actors in these 5 actors. The first one, the BNF provider. This is basically the actor that will provide the BNF packages for the vertical applications. Verticals are mainly the people that know the service that has to be tested, including the SLAs and service components and so on. So basically, they will provide requirements to the other actors. After that, we have the experiment developer. In the experiment developer shoulders, this is the main task has to be developed here. Sorry, guys, if you can mute yourself, please. Thank you. So as I say, this user has the knowledge about, first of all, the 5G infrastructure. This is important for them to know at least what we are providing, as explained in next, the details about the blueprint and so on, and also some expertise about. Sorry, please. Can you mute, please? I mean, we can answer questions after the presentation. Thanks. As I say, they have some expertise about the NFV network service modeling. And after experiment developers, we have the experimenter. This is the actor responsible for the request of an experiment. Okay. After the experiment developer has provided everything, the experimenter can use those information to actually run the experiment and also analyze the result of the experiment. And finally, the site managers are the one that has control of each site that we have in our project. To know these actors is really important because the tools that we are providing, basically using the portal, are somehow distributed using having this in mind, having these actors in mind. Okay. So as I will show you later, the portal is very related with this actors division. Another important concept in our platform are the blueprints and descriptors. I will not go into detail about the blueprints and the descriptors. As you see here, there is some more information in some deliverables, right? Basically, deliverable 4.3. Okay. But what is important is that first of all, the experiment developer, the actor that we have defined before, is in charge of the first part, the experiment design and definition phase, which is the first block we have on the left side. And the experiment developers have to define the vertical service blueprint for a given vertical service. They can also define the context blueprint. The context blueprint are mainly the operational context that we are including to execute experiments and to define the context that is where the vertical service has to be tested. We also have in green the test cases blueprint, basically all the tests that we want to run on the platform, like sending, I don't know, pins information or sending, generating background traffic, whatever. We also have to define the key performance indicators, the KPIs, and we can also include everything in our blueprints. After defining all these elements that we have on the left side, the next step for the experiment developer is to generate experiment blueprint. But in this case, this is basically a kind of composing all the previous, using the previous blueprints, composing an experiment that can be instantiated at the end. Okay. So the result of this stage is to have this experiment blueprint. And with that, at this stage, the experiment developer finishes his task. And then the experimenter, that is another actor, is the one that selecting one of the experiment blueprints that are available on the platform. Then they can specify a very specific experiment that this experimenter wants to execute. Okay. So basically, this experimenter has to describe the experiment. So in here we have to fully describe the experiment. They can also select the metrics that they want to collect. They have to monitor these metrics. They can specify KPIs, and the experimenter can also select the number of tests they want to execute on this platform. After that, the experimenter also can analyze the resulting information. This is about the blueprints and descriptors. In here, in this slide, I present all the steps that we have to follow from the very beginning, from this vertical, till the experimenter deploying the experiment and analyzing the results. So in the first stage, the vertical provide the requirements both to the BNF provider and to the experiment developer. With this information, first of all, for example, the BNF provider can generate the BNFs that are necessary to deploy the experiment. So they, in the second step, they model, define, and onboard the BNFs using the 5G EVE portal. Okay, so what you have in here in between all these users are the tools provided by our portal, by the 5G EVE portal. So after the BNF provider, or in parallel, the BNF provider has uploaded this information, also the experiment developer can start generating the vertical service blueprints, the context blueprints, experiment blueprints, and also the descriptors, in this case, the network service descriptor, for example. Again, I will show during this demo how this experiment developer can onboard all this information using the 5G EVE portal. Also, in the second part of the live demo, I will act as an experimenter. Okay, so I will select, as in this step number 3, I will select one of the blueprints that are one of the experiment blueprints that are onboarded. I will completely configure this experiment blueprint, so I will define the experiment I want to execute. In here, there is something that is under the hood in this portal. So after we define this experiment, the site manager will receive a ticket. Well, we include all the information about the experiment that we plan to execute, and the site managers can, let's say, approve or not this experiment. Okay. So they can also set up something in their own particular site. After everything is ready to be for the experiment to be deployed, the site manager will go back to the 5G EVE portal to accept this experiment, and the experimenter can, in the 7th step, can execute the experiment, and on the step number 8, they can monitor and collect all the results that the experiment has generated. So, as I said before, we will provide a very detailed user manual to access the portal. This will be included in deliverable 4.4 that is ready, but we are in the last quality assurance steps to publish this deliverable. But at the end of this month, this deliverable will be public, and you can go in there to check in detail this user manual. That, as I say here, this is a very detailed manual to assist you to use this tool that we have in a portal. Okay, so this is, let's say, the first part. Now, for the simple use case, as I will not go too much in detail, but I will explain an overview of this simple use case. Well, as I say, this is a very, very simple use case where we have only user equipment and a web server, and we will generate some traffic from the user equipment to the web server to test that everything is properly configured. Okay, so in this particular use case, we are not using the context blueprint. Okay, we are not including that just for sake of simplicity. But in this case, we will use this use case to show you how an experiment developer onboard a BSB, onboard a test case blueprint, onboard an experiment blueprint, and after that, how an experimenter can use these blueprints to create their experiment descriptors, to schedule an experiment, to deploy an experiment, and to analyze the results of the experiment. Well, this is the vertical service blueprint, very, very simple. As I say, a user equipment on one side, an Apache web server on the other side, some service access points in here and there, and another service access point to configure this DNS. Okay, we will publish all the blueprints and descriptors that we will show you today. So you can go there and check how these are defined, how these blueprints are defined. And I will show you this screenshot. I will show you this screen on the portal where we can see the BSB in a graphical representation. After that, I will also onboard a test case blueprint. In a test case blueprint, we include configuration scripts. These are the first scripts that are run after the experiment is deployed. After the configuration, we also can include an execution script that is basically the core of these test case blueprints, where we actually execute some scripts like sending, in this case, to activate the clients to request web pages, for example. We also can include test case user parameters, the infrastructure parameters, and so on. Okay, so in here we have everything. As in the case of the blueprints, we will also publish these slides so you can check what we are including here. Okay, so I will explain all these parameters. I will explain this in the live demo. Okay, so I will also show you the experiment blueprint. This is a screenshot, but I will show you in live demo how these things work. Okay, just to explain a little bit in detail about what is under the hood. First of all, after everything is deployed, after everything is onboarded, and we have the descriptors and everything, the next step is to deploy the experiment. Okay, so with this experiment blueprints and with the experiment descriptor itself, the idea is to run using the multi-site network orchestrator to execute in a given site, in this case in the Spanish site, to contact the NFVO, in this case in our OSM, where we plan to instantiate two different virtual machines. One running what we call where we use the Apache benchmark, that is a tool to run several requests to a web server, and on the other hand, we are running the Apache web server. Okay, The file bits are basically the data shipper that will extract logs from these components and will publish all this information in our monitoring system. After everything is deployed, the second step is to execute the experiment. So using this test case blueprint, the idea is first of all to configure the one of the components of the, in our case, the 5G platform. So the first step is to configure, in this case, the file bits that we have in the Apache benchmark element. And after that, in the second step, the idea is to actually execute this script where we are forcing to connect this Apache benchmark device with the Apache web server. Okay. So at this point, we were collecting some of the scripts, some of the metrics that we have collecting in the Apache benchmark device. And after that, we will provide these metrics using the monitoring and KPI information. So I will show you in the live demo how we plan to do this in our 5G portal. Okay, so after everything is more or less clear, the next step is to proceed to the live demo. So let me switch to the, in this case, to the web browser. Okay, so let me find it. Share web browser. Okay. So hopefully you can see my screen. If not, please let me know. Okay, so here this is the 5G portal, okay, where we have all our tools that we are providing to all users. In here, the users have to first of all register. Okay, in our case, I have an account that is already valid. Okay, in this case, this account that I'm using right now is valid for different roles, for an experiment developer and also for an experimenter. Okay, so in this step, we have the main screen in our portal. So in the big green button, we have what we call the design experiment. This is basically useful for the experiment developers. Okay, so basically, this is the first step where we have to onboard all our blueprints. The yellow and red buttons are mainly dedicated for experimenters. And the blue one here, for example, I cannot click on this blue one because this is intended for a site manager in this case. Okay, so I will proceed first of all as in this case as experiment developer. Okay, so I click here, and there are several elements where I can start. Well, as I say, we will start with a vertical service blueprint. After that, we will onboard a test case blueprint. And finally, we will compose an experiment blueprint at this point. Okay, so let's start with the vertical service blueprint. Okay, here in this case, let me increase a little bit the font size. First of all, we have to upload the blueprint. So we can do this here using this choose file. Okay, so here we have all information is already in my local PC. Everything has to be onboarded using a JSON format. Okay, again, everything is reported in the table 4.3, so you can go there and check what you can do. So in here we have two things. First of all, this is the vertical service blueprint for this very simple use case, the Apache web use case. So I will onboard first of all this blueprint. Okay, so this is onboarded, so I can click on next. So this is the second step is to upload the NSD, the network service descriptor. In here we can choose a static deployment where we don't need an NSD. But in this case, we need an NSD, so I will choose, in our case, this NSD that I have already in my PC. And in that case, I can upload this to the server. Okay. So clicking next. In here, there is the NSD information. This is an UUID. This is the version. And here we can select the flavor ID in case we have several flavor IDs in our network service. In our case, we only have one. So when I click here, the portal show me only one. So I select this one. And we can also select one of the multiple level instantiation levels that we have in our network service. Again, I have only one because this is a very simple use case. So I select that instantiation level. Again, there are other parameters, like in this case, for example, the number of user equipments. Okay, let's say that I can define like from 1 as minimum and 5 as maximum. Okay, this also depends on your service. Again, remember that this is just a vertical service blueprint, and we have to specify the proper number of user equipments when we are in the descriptors, when we are defining the descriptors. So I submit this, there is a success, so I can go back to the view part, okay? And here, sorry, and here I can reload this, sorry, let's go back. And here we have our new vertical service blueprint onboarded, okay? So this is the first step for the user, in this case, experiment developer. So next, let's go to the test case blueprint definition. That is this case. Okay. In this case, we are always improving the portal. So right now we have two ways to include this test case using these input boxes, or you can onboard directly. In this case, using this switch to TCP upload via JSON file. We can also onboard a JSON file that we have in our devices, in our PCs. In this case, I will select this one. Okay, so I will submit it. This is a success. So let's go back. We have to reload it. Okay, so here we have our new TCP. Okay, in the TCP, I will explain later that we have several parameters that will be requested to the experimenter when the experimenter is creating each experiment. Okay, so there are several parameters that this experimenter has to fill in order to create the descriptor. Okay, so we can go back. We have the vertical service blueprint is onboarded. The test case blueprint is onboarded. Remember that in our case, we are not using an execution context blueprint. Okay, this is our blueprints to generate context, to generate real conditions in real scenarios. But here we are not using these blueprints. So now the next step is to create our experiment blueprint. Okay, so in here there are several steps. This is the first one, and you can see here there are several steps. This is a guided wizard, so we can start creating our blueprint. First of all, we request a blueprint ID. Okay, so for example, we can, let's say, put any number, any name. So for example, let's say this is our ID and blueprint name. Okay, so we can say, for example, this one. Okay, so we can modify anything that we want. Okay, so this is the name, blueprint version. So this is the first version. So this is version 1.0. A blueprint description. Okay, so we can include whatever we want here. So for example, this is another unique description. Okay, and the deployment type in here, we can select on demand, or static. Okay, so this has more information. This is more information. You can find it on the user model. Okay, so in our case, we are using on demand in this case. The next step is to select one of the multiple vertical service blueprints that we have onboarded. Okay, so in here we can filter out other vertical service blueprint. It's important to remark that each vertical service blueprint is intended to be deployed in one or multiple sites. So for example, if I select here the Madrid, Spain site, in the vertical service blueprint here in this part, we can also see only the elements that we have onboarded that are compatible with the Spanish site. Okay, so for example, I will select this one, the simple vertical service blueprint that I have created just before. In the next step, I can select the context blueprint. As I said before, we are not using context blueprint, so I can click here, no context blueprint, and I can proceed to the next step. That is onboard the composite NSD. Okay, so in this case, the idea is that we have an NSD that is a composition between the vertical service blueprint and the context blueprint. In our case, we have generated this by hand, so we have it here. This is the experiment, the NSD for our experiment blueprint. There are also tools that you can use to compose your NSD, your experiment NSD, and this is an offline tool that you can also download in our GitHub from the 5GE GitHub. Okay, as I say, this is the onboarded NSD, so we can click next. So we are now in the translation rules. Remember, these are the translation tools rules that we have in our BSB, in our NSD, sorry. So now we can select one of the flavors. I select this simple flavor. The instantiation level is this one. And in the number of user equipments, again, remember this is a blueprint. I can select a range of values for this case. Okay, so for example, from 1 to 4, and I click here. Okay. So next step is to select the metrics and KPIs. Okay, so in the first part, you can select your infrastructure metrics. We are not using infrastructure metrics in this very simple use case. So we can proceed to create the KPIs that we have in our, that we want to test in our use case. So for example, we will use a very simple KPI that is basically the same metrics that we are using in our use case. Okay, so let me check. I have it somewhere here. That we can select these metrics that we have. We have to go to our BSB, and in there you can find the values that you can use in here. So let me go to that point. Sorry, I'm opening this element in my PC. Okay, sorry. Okay. Okay. Yes, so the metrics I have included in my BSB is this one. Sorry. Is the request time taken. So remember that we are generating requests to a web server. So this is a metric that will publish a metric that will, let's say, report the time taken by each of these individual access to our web server. So basically, our KPI, this is an equation, a formula, is directly this value, the request time taken. Okay. So the units will be in milliseconds. The interval that we will, let's say, collect these values are 1 second. The KPI ID is anything we want here, for example, time KPI ID. The name is time, for example, KPI name. And in here we can select the graph type. So for example, this is a line. We can select also pi, counter, gauge, whatever. So I will select the line, and in here, because we are only using this request time taking, I will include only this parameter, this metric, okay? This is a comma separated values, but in here we are only including one. So this is the metrics and KPIs. So we can move to the next one, that is the test cases, okay? In this case, the test case I will use is this one. This is the last one I have onboarded. These are previous tests we did today. So after we submit this experiment, we have a success here. So we can go back and view our new experiment. Okay, we have to probably to reload our portal, and in here we have our new experiment. Okay, so we have onboarded, remember, a vertical service blueprint, a test case blueprint, and an experiment blueprint as an experiment developer. Okay, so now remember, because I have the two roles, I can go to the request experiments as an experimenter role in this case. Okay, so in this point we have three different ways three different services in this part. We have the experiment descriptors create. This is a wizard where we plan to follow to create this experiment descriptor. But there is also an intent declaration where we can do something similar to the previous two steps that we have here. Okay, I will show you the way to generate these descriptors using the top services. Okay, first of all, I will create an experiment descriptors, and after that, I will schedule an experiment. So first of all, the experiment descriptors, in this case, I will start selecting one of the experiment blueprint. Okay, so here I have three. Well, the experiment developer has generated three blueprints, three experiment blueprints. I will select the last one. Okay, so here I have to provide a name. So this is a simple descriptor. Okay, so here is, for example, today. So this is very late, but and the version, for example, is this one. We can proceed to the next step, that is the vertical service descriptor. Again, here we need a name for this. So PS descriptor, okay, version 1.0. And here we can select, remember that we are defining a descriptor. So here we can select the number of user equipments we want to run in our experiment. Remember that in the blueprint allows to have from 1 to 5, but in here we have to select the proper number of clients that we want to execute. In our case, we will only use one. In the slice parameters, we can select the management type. Okay, so again, this is there are two types: provider managed or tenant managed. In here, the own infrastructure will manage this experiment. So we select provider managed and the type of service. Okay, so in this case, we will use this this use case. Okay, and well, we will not make this public, this experiment descriptor public. So we can move to the next part, that is the KPIs. Okay, so remember that we have defined only one KPI, that is the time KPI name. In here, what we are requesting is a threshold. Okay, remember that our infrastructure, our platform will validate or not the experiment when the test finishes. Okay, so in here we have to provide a threshold. Right now, this is only a maximum threshold. Okay, so for example, if I say here 40, remember that the units that we have declared are milliseconds. So if our experiment, if any request takes more than 40 milliseconds, the experiment will fail. Okay, we plan to improve this to also include the minimum KPIs and other values here. But right now, we are including the maximum threshold for our KPI, 40 milliseconds. The next step is the context details. Remember that we don't have a context, so we can go to the next step, that is to test, to configure the test case, okay? So we have selected this test case, okay? These are the user parameters. In here, we have to declare the number of concurrent clients that we have to run with our Apache benchmark. Okay, so for example, 4 concurrent users. The number of requests, we will generate 3,000 requests. This is the password. Right now, we have to include this information here. We will improve this to use private and public values. This is another value that we have included in our test case blueprint, the sleep time, 10 seconds, and the user, this is also test. Okay, again, we will modify it in the next versions to allow also public and private keys. Okay, so finally, we have finished with this, so we can click submit. And right now we have declared a new descriptor. Okay. So in here, we have to have this new descriptor is in here. Okay, so this is the new one. So now the next step is to schedule the experiment. Okay, so we have a descriptor, but we have not requested to schedule this experiment. Since in this stage, we can request a particular day where we want to execute this experiment. Okay, so for example, this is the experiment, this is the scheduling. Okay, so for example, schedule. We include here the date, for example, just not to forget. And in here, we select the experiment descriptor. Okay, we will select the last one. Okay, this is the one that we have just declared just before. The target site. Here, this is the only site that we have declared, the Spanish Pythonic. The use case, in this case, we are using a use case to share these results with other users. So for example, all users that have this use case can check the results. So all users with the Apache can select this, can see these results. The start date, okay, we plan to start today, for example, and we want to finish our test tomorrow, okay? So this is the steps that we have to do to request an experiment. Okay. So in this case, we have requested this. This user has requested a scheduling of an experiment. So in this case, we have checked that there is a user that has a pending. This is the status is scheduling. So here the user is waiting that the site manager accepts this experiment. As you see here, I cannot go to the managed site, so there is another user, in this case the site manager, that has to go and accept this this experiment. Okay, so there is another interface where we can do that. I'm trying to do this under the hood, so I will accept this experiment. Okay, so the user can move to this other part, that is to manage the experiment. And in here, we know that this experiment that we just created is in the status accepted. Accepted means that we have accepted this, the site manager has accepted this experiment, but we are, or the site manager in this case, is waiting to configure everything to be ready. Okay, so after in this case, the site manager, the Spanish site manager, has everything configured to execute an experiment, then we can see that there is a new status of our experiment. That is, sorry, wait a second. Okay, so the site manager will change the status. In this case, the experimenter can refresh this experiment, and now the experiment is ready. Okay, so now at this step, the experimenter can deploy its experiment. Okay, so in here there is a new button, a new icon here that where the user can deploy this experiment. Okay, so first of all, I will explain you before that what is under the hood. This is our open source manual. This is our private, let's say, interface where we are managing all our services. So here, for example, we have only 2 instantiations running, but after we click here under deploy, okay, so I will click submit. Okay, our portal say that is success. So under the hood, what is happening is that the portal is contacting, in our case, the interworking layer. This is another layer that is in our 5G if platform. And in that case, the interworking layer is contacting the Spanish side, in our case, our OSM. So you can see here that there is a new experiment, a new NSI that is basically in the init status. Okay, so we only have 2 virtual machines. Remember, the client, the user client, and the web server, and we have basically 2 networks. Okay, so they are deploying these 2 networks. This will take around 1 minute to deploy everything. Okay, remember, this is a private interface. The user, the experimenter, is only receiving the status here. In our case, the status is instantiating. Okay, so basically, the user, the experimenter in this case, has to wait till the experiment is completely instantiated. Okay, so we can check here that the experiment has the OSM has created the 2 networks, has created one of the 2 virtual machines, and yes, everything is instantiated. We can go back. Okay, so after this is instantiated, we need some time, because remember that we have several components there, but finally the user is in the instantiated status. Okay, so right now the 2 virtual machines are deployed, and well, the next step in our case is to execute the experiment. Okay, first of all, let me show you more information about this. So for example, in this case, we have the whole information about the IP addresses of all these devices. Okay, the experiment is instantiated. So right now, what we can do is to go and proceed to execute more tests. That in our case is just a matter of clicking in this button that I have showed you before. Okay, so let's go back. And in here, I will click on execute. Okay, remember, basically the execute is to execute our test cases. Okay, in our scenario, it's a very simple scenario, so we only have 1 test case. Okay, so we will execute that test case. Okay, we will include a name for the test because we can run several times this test, just in case we need to execute all these experiments several times to get more results, whatever. And in here, we can click on submit. Okay, so they say success. The experiment is running the execution. Okay, so we are waiting. We have to wait. Remember that it will take some time to execute all the experiments. So we have to refresh our interface just to check that everything is going well. Okay, I here under the hood checking that everything is going well. Okay. This is still running the execution. So we are in there. Remember that we need to configure the execution. We need to configure all elements first of all, and after that we have to run the proper scripts to in this case to run the Apache benchmark to to stress our web server. And after that, we will finish with a reset script. Okay, let me refresh again. Well, the test case has completed. Okay, so we can analyze all the results that we have obtained. Okay, so here in the previous screen, the experiment went back to the instantiated. So we are again available to execute a new experiment if we want. Okay, but first of all, let's check the results that we have obtained. Okay, remember that we have defined one metric, that is the time taken by each request, and one KPI. Okay, so let's check all these results. So we have these two, let's say, screens are showing these results. In here we have the average metric value. Okay, so this is an average every 1 second of this. Remember that the time taken for each request. Okay, so the time taken is around 35 milliseconds. Okay, and on the left side we can see the KPI. Okay, so this is the KPI value. Okay, remember that we have declared a threshold of 40 milliseconds. We can see that almost all values are below 40 milliseconds, but there are some values that are above these 40 milliseconds. So in this point, for example, we have some samples with 41, 42, and in this case with values near to or close to 80. Okay, so what is this result? How we can analyze these results? Well, if we go back again to this summary of the test, we can go to the report. Okay, so this is a validation tool that we have implemented that basically analyze the result of this test. Okay, so for example, we can find that the experiment has failed. Why? Well, because as we say, we have included an upper band of 40 milliseconds, but there are some samples that are above these values. Okay, there are some values that are 44, as I said before. Okay, well, if the user, if the experimenter doesn't care about some samples, probably they can change the experimenter to include like an average instead of the value of the proper value of the access time. Okay, anyway, at least the experimenter can check why the experiment has failed, and then they can try to improve a little bit their experiment or any other, let's say, improvement they want to include there. Okay. So with this, we can conclude this simple use case. And as I say, we have created a new or onboard a new blueprint as an experiment developer using the design experiment. Then as an experimenter, we have defined the request experiment and so on. And finally, we have deployed the experiment using this functionality that we have here. Okay. So as I say, with this concludes this presentation. So if you have any question, please let me know.
Thank you, Jaime. I didn't see any questions in the chat. Are there any questions from the audience?
Crystal clear, I guess.
It was very clear, but let's give people time a little bit to think about it too, and we can take them also after the second.
Sure.
The second presentation.
Sure. I will stop sharing so you can handle this. Okay.
Oh, okay. Thank you, Jaime.
Thank you.
So Pablo, are you ready to take over here?
Yes. So I guess I can start sharing.
Go ahead. Go ahead.
Okay. So if I go full screen, can you see my slides?
Yes, I see them fine. Everything's fine.
Okay. Thank you, Raymond. Okay, now we're going to jump into the second use case, which instead of Hello World use case is more of a practical scenario. Of course, there is a lot of work, as Raymond commented at the beginning. There is a lot of people working to make this possible. I'm just mentioning the different partners of the project. We have Segitur, Yerbabuena, Ericsson, Telcaria, Wing, IMDEA, and UC3M. And well, that's me, Pablo Serrano, giving the talk on behalf of this awesome team. And well, first of all, if you remember the different roles that we have in the project, basically what I'll do is to follow, well, there is going to be a number of speakers in the slides as I'll present later on, but we're going to follow this order. I'll start talking at one of the site managers of the Spanish site to provide some background about the site facility in which we are deploying this use case. And then we'll illustrate in a very summarized way the procedure on how we have envisioned the methodology to follow to address a vertical and then eventually having the deployment of a use case in our scenario. So I'll present how to engage with the vertical, how to design this use case, and then later on we'll change hat and speakers. So then the experiment developer will jump in and describe how to design and prepare the experiment, setting it up in the 5GF portal. Of course, this is the role of the experimentant, and how to execute, monitor, and analyze the results. As I mentioned, there will be a number of speakers, Pablo Serrano, myself for the first 2 points, and then Diego Isaac will take over for the rest of the steps. So first of all, to give a quick summary, a quick overview about the site facility that we are going to use for this use case. As you know, in the project, we have up to 4 different sites. This use case is about the 5-tonic laboratory. Of course, you have all the details in the different project deliverables on the website. Basically, this 5-tonic laboratory is a facility that we have in Leganés in Madrid, in which there is a relatively large common area in which you can run a number of experiments. This one on the smart tourism, but also we have other use cases about the industry 4.0 or even on gaming. And as you can see, you can have different experiments running simultaneously over our radio infrastructure. And there is a data center, not well, it's just pointed but not shown in the picture, in which we have a number of servers with large capabilities and also ensured power supply, although we had some issues past weekend, in which you can deploy your virtual infrastructure on the software to support these experiments. So as of now, well, this is to give an overview of what was the roadmap of the project and how we are deploying the various 5G capabilities, 5G in the standardized sense, and then the different added value features of the project. So as of now, we are almost in July. So starting on the 1st of July, this is the type of capabilities that you should be expecting, well, regarding the Release 15, 5G New Radio, MIMO, and on the 5G side, and then on the 5G side, sorry, and then on the 5G EVE side, well, starting on July, we'll have the portal that Jaime just introduced, the analysis of different KPIs, and we'll start onboarding the services from other ICT 19 projects. So, and this is very much related to the use case that will be presented later on in the 5-tonic facility. We have been, and we are periodically running experiments to test the performance of our radio parks. So in the figure, you have a summary of the different peak rates in the downlink and on the left side, and in the uplink on the right side, depending on the different bandwidth and configurations that you use for your radio. So for instance, we have configuration of up to 50 megahertz of bandwidth and different 421s, 723, 321 configurations. And well, basically what you can see is that the performance that we measure, which is the one in the green bars, also reported on the table, it's between the theoretical maximum under ideal conditions and the minimum that we're expecting. So on the downlink, you can see that the best performance is given for a certain configuration, and on the uplink, which is the configuration that we are going to be dealing with for this use case, the best performance is up to 54 megabits per second for the 7.3 configuration. And another quite relevant, interesting feature of our Photonic facility is that we have these 5G terminals, but of course many others have, but also we have instrumented them so they support remote access and execution of the experiments. So there is no need to jump in and to access the lab to run these tests, but rather we can, and we have been running remote experimentation. So in these COVID-19 times, it's great because then we don't have to get through all the security measures and procedures to adhere to the safety guidelines. Okay, so that's on a quick summary of the selected site facility. Now let me introduce you to the vertical use case that we're going to consider prior to dealing with the actual technical details on its design and execution. So in a nutshell, the vertical use case that we're considering is the stream of a 360-degree video recorded at an event. And the motivation is clear, as we have, well, there are some estimation about the bandwidth that you require to stream this type of video with 360 degree, around 50 megabits per second or more. And the motivation is that while for static setups in which you have long-term deployments, you could of course think about deploying the wires and having a wired access to your equipment. For the case of temporary events, for the case of temporary deployments to cover a ferry or to cover some sports events, it would be much more convenient to have a ready access to be able to upload this content. And the problem is that not only with 4G, that this relatively large amount of bandwidth, this 50 megabits per second, may not be available, but also the performance may be so-so. You may not have a static guaranteed performance enough to transmit this video. So that's why we are jumping into 5G. So the motivation is to deploy a use case in the Photonic lab to test if with the 5G different configuration, we can guarantee enough quality to be able to stream a 360-degree video, such as the one that we have in tourism fairs or in other type of events. So what we will be focusing on today is the left part of the figure. We have a camera mounted on a tripod. This tripod is connected to a CPE, to a particular equipment, and then we would want to test if the performance of this 5G uplink, the 5G radio, to be able to transmit the content that is generated by the camera into the Amazon cloud. So we are focusing for the time being on this left part, on the uploaded information. Then, of course, you may say there is the challenge of the video distribution, but this is not on the agenda today. So if this is the use case, we can follow this following methodology in which we address the vertical with the different questions: why, what, how, where, when, and who. That is, why? Well, first of all, why you want to deploy this use case, what is your intention. Then what is exactly the use case that you want to deploy, and how, what are the conditions that you want to use, what are the test cases that you want to check, where you want a deployment, and so on. So this methodology, particularized for the case of the use case that we're considering, would be why? Well, we want to have a stable communication so we can transmit this 180 or 300 video production with the required quality. Then what we need is this full solution to be able to transmit this video. We need in principle up to 50 megabits per second of throughput. If you remember the slides 3 ago, yes, we can achieve this under ideal conditions in the test bed. As we mentioned, because we have, according to our measurements, we can reach up to 54 megabits per second. So if the requirement is 50 megabits per second, this should be feasible. And when, well, we have this plan for in 2 validation campaigns for non-standalone and standalone. And who? Well, there is this number of partners, Yerba Buena with Segitur, and also with a lot of support from Nextworks. So I guess this is all from my side. So now I can pass the ball to Diego.
Hello. Yes, I will share my screen.
Okay.
Sorry. Okay, hello. So I am Diego San Cristobal from Ericsson Spain, and I will be covering the part of the experiment design and the preparation, and also how to set it all up in the 5G portal. Then, according to the 5G workflow, these two sections cover the test design and the test preparation. The test design is the preparation of the blueprints and also the onboarding of the blueprints by the experiment developer in the portal. And the test preparation is carried out by the experimenter, who customizes the experiment, requests the scheduling of the experiment, and well, also the site manager is involved here to accept the scheduling of the experiment and to let the experiment ready for execution. So to be able to prepare the blueprints, this is the setup that we have in the lab, where the camera and the production server is connected to the 5G network infrastructure there in the lab, and the video traffic is able to reach the server on the internet. And note that the service is provided by Yerba Buena, and it's not under the control of the 5G domain. The service application is out of the 5G domain. And we also have dynamic probes, where they can be dynamically configured to collect the metrics that the experiment needs, collect the information, and send it to the 5G platform for the part of the validation of KPIs and analysis of results. So summarizing, these are the key components, the things that we have to model, which are the camera and the server, the internet server that receives the video streaming. Then we have the 5G non-standalone network infrastructure. This is something that we do not have to model in the service blueprint. And then we will have to specify the metrics that we want to collect, and we are going to focus in this user case in the user data rate for the uplink and the latency of the user plane. You will see it bigger like this. So for the vertical service blueprint, we have two components, as I said, which are the camera and the server, the internet. These components will have a connection point of the camera and connection point for the server. And we define them also here in the endpoint section. And also we will be having the two virtual links that will connect to each of the components through the connection point. The test case blueprint, in this use case, we only need to specify a script for providing some sleep time for the metrics to be collected. And this is what we will onboard later. And then in the experiment blueprint, what we will specify are the metrics, the infrastructure metrics, and the KPIs that we will show. So for the metric IDs, they are the user data rate for the uplink and the latency user plane. And in the KPIs, the formula will only refer to those metrics. You could put a full formula here, but we are just showing the KPIs, the same value as the metrics. So to set it up in the portal, we are going to use the Madrid facilities, and we will see it now that I will use the design experiment part to upload the blueprints, then the request experiments section to define the descriptor and schedule the experiment. Then I will go into the manage site section to accept the experiment, and then to the manage experiment to execute it. I am moving now to the actual portal. I will log in here and start uploading all the files. Okay, let's go first to the onboarding of the vertical service blueprints. This one I will do by uploading the JSON file. So you come to the JSON file. I will select a static deployment, because in this case, as we don't have an application that is controlled by the 5G domain, we are not don't define it here with an NSD. So it's a static deployment, and we'll submit. Okay, now coming to the view list, we can see that it's onboarded, and they have a vertical service blueprint onboarded for the video. So now we are not using either the context blueprints. I'm going to onboard the test case blueprints where we specify the commands, and I will onboard it with the wizard that we have here. So it's first requesting the name for the test case blueprint. I'll paste it from my file. Then the description. Let's type the version. And here the configuration script and the risk configuration script are not mandatory, but the execution script is mandatory. And we're only configuring here the sleep time for the metrics to be collected during this time. And we have to specify how will this value be requested to the experimenter. I'm setting the sleep time. Now I can submit. This is refreshing, and now if we come to the view list, we will see that our test case has been onboarded. Let's go now to the next one, which is the experiment blueprint. And here I will follow again the wizard to fulfill the onboarding. It's requesting first the ID. Here. A name for the blueprint. The blueprint version I'm using 4.1. The description. The deployment case type in our case is static, as we are not using DNFs. So the next step, we select Madrid, Spain. We select the vertical service that I onboarded earlier, and we come to the next one. We are not using context blueprints. Moving on. And here, it's the section where we configure the metrics. So first, the metric will be the user data rate uplink. We will measure it in megabits per second. We can set it, for example, every 10 seconds. I provide a name for the metric, user data rate in uplink. It's going to be a collection type gauge, and the graph type is going to be a line. So this is metric 1, and I will configure metric 2, which is for the latency user plane. The unit, we will select milliseconds. It will also collect the results in a 10 seconds interval. The name can be this one, and latency. Collection time also gauge, and graph type line. And now we need to fulfill also the KPIs. It requests in the first place the formula. So one formula will be equal to the user data rate metric. Also, we'll be measuring it in megabits per second, 10 seconds interval. The ID for the KPI, I will set this one. It also requests a name, so it's user data rate KPI. Graph type is going to be a line, and here I also need to paste the metric ID. So I will copy and paste the same name for the metric ID. And we need to insert also the KPI number 2. This one is referred to the latency user plane. So I'll copy and paste the latency user plane here, both in the formula and in the metric ID. These units are in milliseconds. The interval will be 10 seconds. The KPI ID is going to be KPI latency. And the name, end-to-end KPI. Okay, so this part is ready as well. I will go to the next section. Here I have to select my test case blueprint, which is this one, use case 51. And I'm submitting. Well, so it looks like it's not answering right now, but I have my backup slides. I will end up showing how to do this here. It should have been onboarded, and then we would be able to see it in the view list for the blueprints. Then here in the list of the blueprint, we could move to the experiment blueprint details and see the details of the blueprint. And then we move on to the experiment part, where the first step is to define the experiment descriptor. And we would follow the wizard and include all the values, the experiment blueprint that we are going to use. We provide a name, an identifier to the descriptor. We also select the version of the descriptor, and then we move on all the different views. We cover all the steps. We set the thresholds for the user data rate and for the latency. Moving on, as we are not having any context, we would move to the next step. Then we have to select the test case that we have onboarded, the test case blueprint, and then it requests to the experimenter what to put for the user parameter that we set in the blueprint. And in this case, we are setting, in this testing, we've been setting 40 seconds to wait to collect the metrics. Then we press on submit, and the experiment descriptors will appear in the list with all the details we have configured. You can go into the descriptor and check the details in detail. So the next step is to schedule the experiment, and it's just a matter of selecting the site where you're going to run it and the time, the date for today, and the days that you're going to be running it. So when you perform this order, the site manager will receive the details of your scheduling, and we'll have to come to the experiment and perform the action for accepting it. It will accept it, and then when everything is ready for execution, he will set it as ready, and the experiment descriptor will appear then as ready, and the experimenter will see it then in the manage experiment section. And first the experimenter will deploy this experiment, and when all the service is deployed, then the experimenter can perform the action of executing the experiment on the portal. So, well, now I will hand over the presentation to my colleague Isaac. So please, Isaac, when you're ready.
Hello, good afternoon. Thank you for joining, and thank you, Diego, for this handover and your good explanation. Let me share the presentation to follow up it. One moment. I think. Sorry, I have first to share my screen. And then, let me see if I can do it. Yes, I guess that you are seeing my screen.
Yes, yes, we are.
Yes, that's fine. That's fine.
Okay, thank you. Sorry, so I have to go down. Okay. Okay, thank you, Diego. Sorry, I was just setting up the scenario. Well, my name is Isaac Quintana, and I'm part of this Phictonic team. In my case, I'm responsible for the radio part of the network, and I will guide you through the experiment that we are right now in real life doing it. So it will be a good view to see how it is going. Okay, we are now in the part of the test execution and monitoring and result analysis part of the 5G workflow. Well, once the test design and test preparation have been done, where we have selected the 5G environment, we have created the blueprints and customized the schedule of the experiment, it's time for the execution and monitoring part. The environment is just set up. We execute the test, monitor the graph to see the KPIs we want to measure. If you are doing an experiment, normally you can start the experiment and this is done automatically. So you can rest, you can take a coffee with a colleague, or maybe you want to continue doing another task, but you don't have to follow up till you have at the end the result. But in this case, we are going to see the experiment, how is it going, because it's our first time and it's a good way to see how is it working. So we have set up, we have split the window in three parts. There is a left part in the top left part. There is the visor. As Pablo told before, we have remote access to the lab of Phictonic, and we have control of the UEs and the CPEs to just so we don't have to go to the lab. Then in the left screen is our monitoring KPI window, is our dashboard. We call Grafana, and it's similar to Kafka. We just use to follow up the experiment that is going good, but locally. And in the bottom left part, we have the live streaming video. That in this case we have the camera recording the Phictonic lab. We see on live how is it going. Just to go a little in detail each window. This first window is what Pablo told, is a remote access and control to the terminals. This has been very useful during the COVID lockdown, and I have to congratulate the Phictonic team, Neftali and Ignacio, because they have helped a lot and they have done a very good work and very fast to have this set up. So this has reduced a lot our visit to the lab, and we have worked in a lot of configuration, like it has seen before, to change the TDD pattern and to test different configurations in radio part and in core part. The second window that was in the left is this dashboard of monitoring, where we are follow up the three different KPIs important. That is the latency in milliseconds, the user data rate in megabits per second, and the throughput cell. In this case, the user data rate, as we have only the throughput cell, will be very similar to the user data rate, as we only have one UV performing in the network. And this last window that will appear in the top left is the video recording. The camera is sending the image through the 5G UECP towards the 5G Ericsson system, the radio and core part. Then we just put in our college platform, Yerba Buena Virtual Reality, that they have it hold in the Amazon Web Service. As you can see, as the video is on live streaming, we have a URL that you can copy and paste in your media player, like VLC or Windows Media Player, and you can follow up this 360 degrees video. But let's go on directly in the experiment. Let me, sorry, here. Okay, this is the main board. Okay. So I have told you before, we have the terminals here. We have this Xiaomi Mix Mode, Mix 3 5G that we have connected to the 5G network. We can see if we run at iPerf, you can see that we have traffic in 5G. This speed of 50 megabits is property of a 5G system. Also, we have our SACOM CPE router where our camera is connected, and this is transmitting in 5G towards the network. And in the right, we have the dashboard. Let me put a little bit bigger this screen, because this is the video, and as you can see, it's a 360 degrees camera where we have, well, our colleagues have pointed in the middle of the Photonic lab, and we have a view of our lab. As you can see, also we have the time. Also, is the Spanish time, that is 42 minutes 31. There is a small delay of 3 seconds, but you can see that it's a live recording. They are recording right now. Our colleagues are talking here, and also here you can see our 5G antenna and our non-standalone system, where we have our 4G antenna and 5G. The router is here. Okay, the camera is just in the center, connected through the router, and the router is transmitting the 5G signal towards the antenna, and then goes through the cable to the core part that we have in this portable backpack that we use to move for a demos. We move this system for the demos that we want to show. While the video is recording, we have a similar system like, let me put a little bigger, a similar system like Kafka, where we can follow up the measurements of latency, throughput, that is the video recording. I have to update this every 50 seconds. Okay, and this is ongoing. Okay, and this is the experiment that is ongoing. Will show the KPIs in Kafka. Then let me come back again to the presentation. Sorry, I have to go fast down. Here, okay. Okay, then in Kafka, we once the experiment is done, we have this experiment is done automatically, and then the platform of Kafka will show the values. These values are similar to the ones that we took in Grafana locally. And here in the first screen, you will see the report or in the 5G portal that was explained before by Diego, how to set up and how to run the instance. And here we have the results. This first screen shows the value of the minimum, maximum, and average. This minimum and value and maximum is the boundary, is the limits that we put. And if the values of the experiments are in the middle of this, according to what we put as limit, the experiment is considered as pass. We have in this case, we are measuring the KPI, the user data rate, uplink, and also the latency. If you go into detail, you can go into detail in the user, in the uplink, and also in the latency. And you can see during the time of the experiment, that in this case was 45 seconds, you can see each time what is the latency. In this case, in this case the uplink throughput, and also later the latency that we get, and also that is in the middle of the bounds. Just to finish with learning so far for this test case, we did one experiment in June 2nd, also like today, and we saw that using the HTTP protocol, the uplink user data was around 60 megabits per second. However, the delay of the video was increased due to some issues in the video perception. We saw that was not very stable. We thought that was due to the protocol, and when we used the RTMP protocol, the uplink was stable to 20 megabits per second. The quality was very good. We think that this protocol is not as demanding and is more efficient. And even that our colleagues of Segitur and Yerbabuena request for the 180-degree camera uplink data rate of 50 megabits per second, we saw that with this camera, as you saw, of 360 degrees camera with an uplink data rate of 20 megabits or even less, we have a very good performance. You can see that the video was very ongoing, very good, and the perception was even very good. So we can hold the experiment and be satisfied with it. We have seen during some experiments that one of our 5G CPs sometimes lost the 5G connection to this non-standalone system. And if it's non-standalone, when we lose the 5G leg, we continue in LTE leg. The good thing of this is that the video quality was not highly impacted due to this fast transfer from 5G to LTE. And this situation could happen in the real life, and it's nice to see that even with this issue, the video quality and the perception of the audience will not be affected. Just to end point, looking forward to the future, after the execution of this experiment, we also consider to test new features on the 5G radio access part. We have new features considering traffic aggregation, 5G and LTE in this non-standalone system. And this is also support, and we have experiment that we have reached 92 megabits per second in uplink throughput. So this is quite good because we pass from 52 to 92, and we will run this experiment in the following days just to continue developing it and reaching higher throughputs that will support more different cases. To summary all this session, with 5G methodology, new verticals use case can be modeled. So paying special attention to expressing the targeted 5G KPIs. The 5G portal supports vertical experiment to define as many test cases and experiments for its validation through a design, customization, scheduling, execution, and evaluation workflow. And the 5G platform provides great flexibility, as you have seen before, to vertical experiments for such purpose over a common framework and with access to full chain 5G facilities in France, Greece, Italy, and in this last case, Spain, where we have held these two experiments that we saw in this training. I want to thank very much to my colleagues that have before show how the platform is working, and we are very happy to work with this team and to continue growing up with this 5G system and 5G platform. Okay, I want to pass to Raymond that can conclude the session.
Okay, thank you very much, Isaac and Diego. Now, I didn't see any questions in the chat. Before we conclude, are there any questions for either of the two tutorials that you would like to ask from anybody in the audience?
Let me stop sharing. Well, you can see that the project, the video is going on, so we are still all live.
I guess there are no questions. Of course, we'll be open to questions offline. Let me just give you some information about what's coming in the next quarter. So I hope everybody can see my screen here.
Yes. Yes.
Okay, so there are several events in the form of webinars and training sessions that will be coming in the next few weeks. There will be similar demos of the French and Greek sites. I believe it's on the 7th of July. In any case, it's at the beginning of July. And in the autumn, there will be a similar demo also of the Italian site. So these are online demonstrations to give people an idea of what's going on in the different 5G sites. Now, in terms of training, the dates will be defined. We have our project meeting next week, and I suspect that we will fix some dates. From the French site, we will definitely already plan two training tutorials similar to the ones that you saw today, of different nature. The first one will be very similar to the one that you just saw from Ericsson, where again it is a 360-degree video service. Although this case it's an augmented reality video service. So this again will show service creation, deployment by the portal, network configuration and deployment by the portal, and how to collect measurements in a very similar setting, although on completely different infrastructure. Second tutorial will be a little bit less service-oriented, a little bit more networking-oriented, and we will show, and this will be sometime in the autumn next year, we will show how the same network infrastructure can be distributed or locally deployed. So this will be a demonstration of how you can deploy two different network topologies on the fly using 5G infrastructure. One will be a local edge network with localized RAN and core and centralized orchestration, and the other one will be a disaggregated network where you have complete control and user plane separation across two geographic regions. And finally, there'll be another training on the Italian site, similar again to the one we just saw now, on 5G KPI measurements on the Italia experimental 5G network. So that's it. Thank everybody for attending. I don't know if Mauro wants to say a couple of words here.
No, I would like just to thank you, Raymond, and all the speakers today that made a very good job. As said at the beginning, this was a very difficult to organize webinar, but I think that we succeeded in doing it quite well. So my congratulations to all of you. And thanks also to all the participants. We reached something like 45 as the maximum. It is quite good for a very technical webinar. So thank you all for all of this.
Thank you. Thank you.